All right, so here we are. We're going to do the second page on this review for AMC, exponential functions. This problem says to use the properties of exponents to simplify y equals 5 times 4 to the 3x plus 2 into basic y equals a times b to the x form. So we're going to have to remember those properties of exponents here. And I'm going to zoom in so we can have a look. So whenever we're adding values in an exponent, um, we can always rewrite that as split apart with the same base, split apart that addition like this. And it's sometimes easier to see the other way. When we have two bases that are the same, we can take their exponents and add them together and then kind of combine them that way. But we can split them apart in that same way there. So then we have y is equal to 5 times 4 to the 3x times 16, because 4 squared is 16. And then that 5 times the 16, that's 80. So y is equal to 80 times 4 to the 3x. And now, if we look up there, it wants it to just have x in the numerator, but we have 3x in the numerator. And again, we're going to do something here, and it's probably going to throw you off, but you just got to remember that the other way works as well. We can move this either way. So when we have two things that we're multiplying in the numerator, we can think of one of them as we can move it down into the parentheses there. So we have y equals 80 times 4 to the third, and all of that is raised to the x power. So if we were going this direction, again, it might be easier to see that we can take that x and multiply it by the 3 to give us this 4 to the 3x. But we can also go that direction as well. And so 4 times, or 4 to the third power, I believe that is 64. Let me just double check here. 4 to the third power, I've got to put it in correctly, or else my calculator won't do the work for me correctly. Yeah, so it's going to be y is equal to 80 times 80 times 64 to the x power. And that is how we can rewrite this equation into basic y equals a times b to the x form. All right, graph the parent function. F of x is equal to 2 to the x. Clearly label the y-intercept. Clearly indicate the location of the asymptote by labeling it with its equation. All right, so I'm going to need to put on some axes here, and let me see if I can do this kind of nicely with this little trick. Yeah, that seemed to work pretty well. And then I'm going to do that the other way as well. All right, so on my x-axis, my guess is that I'm going to be able to go about every 4 for 1 unit. So 1, 2, 3, there's 1, 2, I'll put in a little hashtag there, 3, 4, 5. All right, and then my y values, I'll probably go by ones. So 1, 2, 3, 4, 5. Oops. 10, 15. All right, so I've labeled my axes there, and it's y equals 2 to the x. So I'm going to do that one in blue. So when I put in 0 for 2 to the x, 2 to the 0 power is 1, so there's 1. And then if I put 1 in for x, 2 to the 1 power is 2, 2 to the third power, oops, there we go, 2 to the third power, 2 squared, so when x is 2, it's going to be 4. When x is 3, it's going to be 8. This is why I spread it out like this with on my x-axis so I can see a little better. And 2 to the fourth power is 16. And 2 to the fifth power is 32, and it's not going to fit on there. So I can then connect those, and it's going to go this way. Try to make it look smooth. Looks pretty good. It's going to look like that. All right, so the y-intercept there. So the y-intercept is 0, 1 is the y-intercept. What does it tell us? What else does it tell us to label? Indicate the location of the location of the asymptote by labeling it with its equation. So the asymptote is right here. Y equals 0 is the asymptote. Put it with a dotted line because it's not part of the graph. All right, now we're going to graph the function of g of x, which is taking that previous function, f of x, and adding 3 onto it. So because f of x is the y value, what we're doing is we're just adding 3 onto the y value. So that means we're just going to take every point and move it up 3 units. So I can just go through and move all my points up 3 units. And that is going to be the quickest, easiest way to graph this function. And now what's interesting is it looks like the blue equation is catching up to it. And the 3 units is just getting to be a less, it doesn't matter as much as we move over to the right because it's going up so fast. And so here the asymptote is at y equals 3 because we moved that asymptote up 3 units as well. So the asymptote also gets moved up 3 units. And we need to indicate the location of the y-intercept as well. So the y-intercept there is 0, 4. And so notice also that the y-intercept went up from 0, 1 to 0, 4. Identify the domain and range of g of x in whatever notation makes you happy. So domain and range, we haven't talked a lot about that, but the domain is going to be what are the x values that are allowed or a part of this function, and it's going to be x such that x is in the real numbers. And you can do that a number of different ways. You can do it like this. It goes from negative infinity to positive infinity as well. That's another way of doing it. You could also say that it goes from negative infinity to positive infinity. That one, so that's the domain. And the range then is going to be x such that, well, x cannot go, or excuse me, y, not x, it's the range. These are the y values. Y cannot, you can't go below that asymptote. So y such that y is greater than 3. And it's not going to be equal to it because that graph never gets to 3, so it can't be equal to. All right. And so the different ways we can do that is we can say y is, whoops, I should add one thing here. I should say we should move in there and say y is in the real numbers and y is greater than 3. And so here we're going to say y is greater than 3. And we can also say that in the range we're going from 3 up to positive infinity. And that would be the way that you can write the domain and range there. Hope that all makes sense. Ask questions if you don't feel convinced about something. And we're going to move on to the next page in the next video.